Alrighty, let's go ahead and get started. Lesson 85, page 598. Again, I highly advise you to have the book in front of you, especially for this lesson. The lesson will be very hard without the book and you seeing the whole picture of it. Here we have finding polynomials, part 2. The first part we dealt with the difference of two squares. Now we're going to deal with the difference and the sum of cubes. We have the formula up there. They have x minus a. I don't like that. I like a and b. A is the first term, b is the second term. I prefer that over anything else. Here we have example 1. They want us to find the roots of this equation. So here we're going to find the roots. We want it in terms of cube. So just like the difference of two squares is just cube. So now to find it, instead of square rooting it, we're going to cube root each of the factors there. If we cube root the first one, the cube root of x cubed is just x by itself. X is your first term, that's your a. The cube root of 27 is 3, so 3 is considered b, your second term. Now, we go ahead and follow this formula. So according to this, it's your first term minus your second term, so x minus 3 times your first term squared plus your first term times your second term, that's what AB means, plus your second term squared, so that's your 3 squared. Go ahead and simplify that even more. You get x minus 3 is equal to x squared plus 3x plus 9. Now, before you go ahead and factor, and this will apply to this lesson, go ahead and find the discriminant before you go ahead and factor. So let's say for this part right here, we're going to go ahead and find the discriminant. The discriminant is b squared minus 4ac. Remember, if it's a negative number, that means there is complex roots, meaning we don't want that. We only want real roots, meaning real numbers. So then it's b squared, which is 3 squared minus 4 times 1 times 9, a times c. That would be 9 minus, what is that, 36, and you get negative 27. So this here is already telling you that this factor here is going to create a complex root. We don't have to do anything else. That means, let's go ahead and avoid this. What we're trying to find is the real roots. So all we have here is x minus 3 equals 0. You're going to set this equal to 0. And you're going to have x is equal to 3. And 3 is your only real root. Let's go to example B. Same thing, very similar. Cubed plus 64. We're going to go ahead and undo it by finding the cube root of each one. Cube root of x cubed is x. That's your first term. The cube root of 64, I believe that's 4. Yep. Which is 4. And then you go ahead and follow this formula. So it's your first term, which is x, plus your second term, which is 4. Make sure you put it in terms of cube before you use this equation. You can't do x cubed plus 64. It's not going to work out. So first term plus your second term times your first term squared, so x squared, minus your first term times your second term, so x times 4, plus your second term squared, which is 4 squared. Go ahead and simplify that. We have x plus 4 times x squared minus 4x plus 16. Now, again, before you do anything, find the discriminant of this, b squared minus 4ac. And this is just because it's a quadratic formula coming out of the cube. And you have here b squared, so negative 4 squared, minus 4 times a, which is 1, times c, which is 16. This will give me a positive 16. 16 times 4 is 64. 16 minus 64 is negative 48. That means this answer is going to contain complex roots. We don't want that. This is not going to work out. Now, the only thing we can look at, set this all equal to 0 after you're done with it. So x plus 4 equals 0. Your root is going to be x is equal to negative 4. So for the trinomials, just be careful because sometimes they won't work out. You're going to end up using the quadratic formula or something else that will give you a completely absurd answer. Example 2. So now we have x to the 6th power minus 64. We could put this in terms of cube. We're going to do that right now. So we're going to put it in terms of cube. So you go ahead and take the cube root of both sides. So cube root of 6, this goes back to the nth root of x to the a power. Whenever you have nth root of x to the a power, this is equal to your exponent divided by your root. That means it's 6 divided by 3, you're going to get x squared. To check your answer, x squared cubed, 2 times 3 will give you x to the 6th power. 64 cubed is, again, 4, I believe. Yep. Now you go ahead and apply the rule here. So according to this, is the difference of a cube. It's going to be x squared minus 4 times your first term squared, x squared, plus your first term times your second term, plus your second term squared. So keep in mind it's x squared, so you're applying the square to the x squared. That's what you have here. So now we're going to go ahead and simplify. If you look at this, this is considered a difference of two squares. That means you could simplify this even more. Put it in terms of squared, so it'll be x, and your other factor will be 2, so x minus 2, x squared minus 2 squared. So then you'll end up with x minus 2 times x plus 2. But you just have to understand that that is a difference of two squares. I'm not going to go into that. Here, we're going to simplify this. We get x to the 4th power plus 4x squared plus 16. This is something that we don't see. We can't factor it. So then you graph it. When you graph it and you have it on page 599, it shows you that that graph does not hit the x-axis. So when you graph it, there is no x-axis. So therefore, there is no solution on that part. It's going to give you complex numbers. It does not touch it at any point whatsoever. Now we go back and look at these two. So when we look at these two, we have x is equal to 2, x is equal to negative 2. These are your only two possible solutions. So it's really easy. Just whenever you see a factor that you can't really simplify, you can't factor out anything else, you just graph it. When you graph it, it doesn't hit the x-axis at any point, so therefore you just go on the other two. Now, x to the 9th power plus 27 equals 0. We're going to go ahead and find the factors of this. So, find a cube root of both 1. So the cube root of x to the 9th, or it's the exponent divided by the root. 9 divided by 3, you're going to get x cubed. X cubed does give you x to the 9th power. The cube root of 27 is 3. Now you have your a and you have your b. So that means go to the formula, which is your first term plus your second term, times your first term squared plus your first term times your second term plus your second term squared. You go ahead and simplify all of this. You get x cubed plus 3 gives you x to the 6th, x cubed times squared gives you x to the 6th, plus 3x cubed plus 9. A lot of high exponents. When we look at this one, this is actually a difference of two cubes. You can take the cube root of each one. So just because you take the cube root of each one, just because your answer is not a whole number doesn't mean it's not a cube root. In this case, it is a cube root. It's a perfect cube. When you undo it, you end up with, so I'm just going to focus on this one for now. So the cube root of x cubed is just x. The cube root of 3 is just 3, the cube root of 3. Because you can't simplify anymore. You're taking the cube root of each one, remember? So then when you undo it, you get the cube root of 3 cubed. When you multiply it out, it does give you the whole number 3. Now you have your first term, you have your second term, and you follow the, just like the formula up here, which is the plus. So it's your first term, which is x. Let's leave it right here. Plus your second term, the cube root of 3, times your first term squared, x squared, plus your first term times your second term, plus your second termed squared. So it's going to be the cube root of 3 squared. I'm just going to apply it to just the number underneath. It's not going to cancel out. The squared and the cube do not cancel out. Only the cube and cube cancel out. Now we keep on going. We have x plus the cube root of 3 times x squared plus x times the cube root of 3. You can't multiply it, so just bring it together. And then plus the cube root of 9, and then I checked in my calculator, you can't find the cube root of 9. It won't give you a whole number. So therefore, that is your solution for just this first part. So again, it goes into a lot of work. This one, you set each of them equal to 0, and that's before we find this one here. So set this one equal to 0, you get x is equal to negative the cube root of 3. This one right here, go ahead and graph it. You know, it's harder to factor, it is a square, but just graph it. And when you graph it, it has it in your book. it shows that it doesn't hit the x-axis at any point. So therefore, there is no solution on this part. It looks complicated, but again, always graph it before. So far your answer is x is equal to negative cube root of 3. And then you go on with this one. The x to the 6 plus 3x squared. Go ahead and graph this too. So when it gets really high, the powers get too high, go ahead and graph it and see where it hits the x-axis. So when you look in your book, it doesn't hit the x-axis at any point. When you graph it, there is no solution on this part. Solution. I don't know why I can't spell right now. Solution. So that means your only answer for this whole thing for B is negative cube root of 3. Last one we have over here is there's a different way of solving for these type of problems. Actually, before we do that, we have example 3. So they're saying find what x is. So what I did is I can't use any of the difference or the cube root over there. I can't factor out any number there. This is just as simplified as it can get. If this is as simplified as it can get, go ahead and graph it. When I graph it and it shows you on page 600, it shows you a graph and it hits the x-axis at one exact point. When you go on to GeoGebra on your phone, you zoom in, you're going to end up with, it hits the x-axis at 2.4542. Again, roots for all these answers is simply where does that graph hit the x-axis. Now, let's go ahead and apply the rational root theorem to it. Here, put the exponents in descending order. Find the factors of the first term and the last term. That's what I mean by C. And then divide your factors of C by your factors of your first term. That's your P divided by Q. And then you use synthetic division. So go back to the lesson and learn synthetic division. I think it's the easiest way to divide factors. Example 4. So we have this factor here. We can't factor any common factor. We can't use any of the special product factors to simplify even more. So we're going to go ahead and apply the rational root theorem. We're going to go ahead and step 1, it's already simplified. It's in descending order, so it's from the largest exponent to the smallest. Find factors of the first term and C. So factors of x cubed, you're only looking at the number in front of it, so that's the 1. So factors of it, it's plus or minus 1. So we have to include the plus or minus sign. Factors of negative 2 could be plus or minus 1 and plus or minus 2. So it's always plus or minus whatever number. Factors of 2 is 1 and 2. And the factors of 1 is just 1. So that means you have the possible factors here. Step 3. So I'm going to go do step 3 here. It's your P. That means your factors of C. So it's your plus or minus 1, plus or minus 2, divided by the factors of the first term. Factors of the first term is just plus or minus 1. When you do that, you divide each one. Here, plus or minus, this is a possible of 6 numbers right here. That means 1 divided by 1 gives you 1. 1 divided by negative 1, or negative 1 divided by 1, gives you negative 1. 2 divided by 1 is 2, and 2 divided by negative 1 gives you negative 2. So in reality, your answer is just plus or minus 1 and plus or minus 2. It's easier to look at it like this. It's over 1, so it's just going to be the same number on the top. Here, this is telling you there's 4 possible solutions you can use to use synthetic division. That's where this comes to play, the x minus a. Here they say use synthetic division to solve for the factors to see which one it can work with. So now, step 3, we have our factors. There's 4 possible, 1, negative 1, 2, and negative 2. Last step, you use synthetic division. So you do x minus 1, x minus negative 1, x minus 2, x minus negative 2. And what that means is you apply synthetic division, and that's what I have over here to save my board. So you have 4 possible answers. You're going to try all 4 of them, see which one works, because you never know which one's going to work. Now, for this one, they have in the book, and I'm using this one here. They used 2 and they used negative 2. When I use 2, I have my numbers here. These numbers are my coefficients. So 1, 2, negative 1, and negative 2. And then you bring your first term down. 1 times 2 is 2, add. 4 times 2 is 8, add. And then 7 times 2 is 14, add. And I get that last number. That last number has to be 0 if it's a factor. So in this case here, 2 does not work out. Positive 2 does not work out, so I can't use that one. Now, I'm going to use -2. And when I use -2, if you notice my work here, my last answer has to be a 0. That's your remainder. That's your last factor here. So if it's a 0, that means you have a factor. So now a factor to this whole thing is, remember this is x minus a. A is whatever number you're using there. So you have your x minus -2 times, if you look here, these numbers are your new factors. So if I work backwards, this is your constant, this is your x, and this is your x squared. So if I look at it, it's x squared minus 1. And that is my factor when I factor this out. So again, you're going step by step, finding factors. You divide and you find your possible solutions to use synthetic division. And 4, you're using synthetic division for all of them and seeing which one works. There's only one that works too. Now, if I simplify even more, I get x plus 2. Here, x squared minus 1 gives you a difference of 2 squares. That means your first factor is x, your second factor is 1. So the difference of 2 squares, go ahead and use it, but I'm going to go ahead and rush here. So it's x minus 1 and x plus 1. Then you go ahead, this whole thing is always set equal to 0. You go ahead and set equal to 0 and solve for each one. If I set each of these equal to 0, I have -2, I have 1, and I have -1. So just set them all equal to 0. And your 3 answers is -2, 1, and -1. Next one here, so where it gets a little bit more complicated. I'm actually going to make 2 videos for this because I'm already at 16. So make sure you watch the second one to see how to do this one right there.